So the class of today is mainly centered around computer architecture, computer organization, and if you have time, you can also revise logic gate, because there are some sections under logic gate that some students are really complaining, especially understanding full adders, half adders, all these things, and how it works, how to answer questions, because I'll also concentrate on questions. Very, very important. Now, before that, I don't know if someone has something to say concerning his worries, things like that, because as you know, we don't have time. So as we are doing something now, it's just to guide you people to go and do more research, work, any problem you find in the group. Precious, yeah. Okay, let me just stop it. Okay, I don't know if someone want to say something before I start. Ito Solomon, I don't understand anything on binary tree. Yes, binary tree is under algorithm, under data structure. Sorry. So as I was telling you, I cannot really take everything in one class like this. So I think algorithm data structure is another class. That one is another class. So another class just to talk about that and answer question under it. So that under algorithm, we are going to work concerning recursive functions, function in general, things like that. Talk about array, linked list, records, okay, binary trees, okay, tree traversal, all the things, prefix, postfix. Voilà. So this one is another class, and there are so many questions there that we are supposed to answer. So you can take another class for that, and maybe during that class we take also operating system. Since we don't have time, you cannot really organize classes every day because I need to work with the ICT student also. So we'll be doing like that. And based on your different problem. But in parallel, what I'm doing, I'm answering past questions. So you go through solution. You have any problem, you come and I will explain this. So this we gain in time, because we cannot really work as in school, like take our time and go through everything in detail. Okay, so another person has something to say before I start. Ito Solomon, yeah, doing a video, yeah, it's possible. I think I will do so. Any other question? If you are ready, please just type OK on the comment section so that let me show people are following, people are listening. If you are seeing my screen, just write OK. If my microphone is OK, then just write OK too. So I'm sure. Okay, I'm receiving comments. Nice. So a minute, let me try to configure this because I don't want people to join the group. I'm supposed to validate each time. It's really taking time for nothing. Okay. Okay. Is everybody seeing my screen? Is it visible? Is everybody seeing my screen? Hello?
Okay.
Yeah, okay, you reply. I need to be sure. Okay, then we are starting. Let me just... Okay. Computer architecture. Now, what you're supposed to understand is generally in computer science, this chapter which is very, very important. In fact, there's no exam without such questions. This is what we call the software part of the computer and the hardware part of the computer. Very, very important. So when we are talking about computer organization and computer architecture, we are mostly focusing on the hardware part of the computer and a small part of the software part concerning this assembly low-level programming language, where we are studying instruction format and so on. So we are coming there because I'm trying to summarize everything completely now. So under computer architecture, generally it is centered on the von Neumann architecture. Von Neumann architecture. Now, and generally for Neumann architecture, you will see something like this here. Here at the middle, we have the CPU. Here we have input unit. Here we have the output unit, and here you have storage unit. And here you have storage unit. Okay, all these related by buses. Now, at the level of the CPU, these are the different components of the CPU. We have the ALU, we have the control unit, and we have multiple registers. Now, so when we talk about computer architecture, the idea is to master all these things. Meaning what the first part generally under this is under input unit, where you are going to store the input devices and so on and so forth. So this part I assume that normally a student is not supposed to have a problem here. Just that is another part under input devices that you're supposed to study concerning data capture. So under data capture, let me just take an example of something like a scanner. Okay. So a scanner in fact is part of a data capture device. So these are devices just used to capture data and send it into a computer for processing. Now generally we have different types of scanners, or scanners use different technology. This is what we call OCR, optical character reader. This is what we call OMR, optical mark reader, or mark recognition. It depends. I explain the difference. And this is what we call magnetic ink character recognition, or you say magnetic ink character reader. So concerning input devices, you need to master also this different technology, very important. So generally when this R here means reader, we are referring to a device. When we say R is recognition, we are referring back to a technology. Let me just take the case of OCR. If I'm saying that OCR is optical character recognition, it simply means in my definition I will be saying that it is a technology used to convert handwritten text or printed text into editable form in the computer. Good. Mean that, for example, you scan a document and you obtain maybe a Word version of that document into your computer that you can really edit. So this is possible thanks to this technology. Now, if the R here is reader, it simply means I will be defining by saying that it is a device. So you start by saying device, in fact, and it works. So by the time you have a scanner that uses this technology, OCR, we call that type of scanner optical character reader directly. But if you want to say optical character recognition, it's perfect, because today it's not always attached to a particular device, but there are some software that really implement the OCR. Like today, even ChatGPT, you can send a document and ChatGPT extract all the different text. So this is thanks to the technology optical character recognition. Now, optical mark recognition or reader, the same thing. So generally, this is a technology used to recognize shaded portion on papers, things like that. Magnetic ink character reader is the same thing, used to recognize magnetic ink on bank checks. So I'm leaving this part, so assuming that normally everything is clear here, because where we are going to concentrate is mostly at the level of the CPU and storage unit, because I want to show you people how to calculate memory capacity. There are so many questions under this, and sometimes students are having difficulties there. So, and from then I will move to addressing mode. So these are the type of questions we'll be answering today together. Now, if I go at the level of now at the level of output devices here, so yeah, I'm just guiding you on what you're supposed to know. At this level, make sure you know when you talk about output devices, say if I can take the case of a monitor. So then if you talk about monitor, you have LCD monitor, liquid crystal display, and we have this liquid crystal display, which is for LCD, and the next one is cathode ray tube, cathode ray tube, so CRT. So you just need to know the differences between the two advantages and disadvantages. Generally, cathode ray tube are all type of monitors. In fact, that uses vacuum tube. LCD is a new type of monitors. But generally, they are known as flat screen monitor, flat screen. So you're going to make the difference. You're going to check the differences between them, because there's one question I think June 2000 and I don't remember the year very well, but they are asking questions concerning this. Now here also you need to know printers under output devices. Make sure you master printers. So under printers, know the categories of printers. We have impact printers and non-impact printers. Know the differences between both of them, very very important, and know example under each. Like example of impact printer, you need to know them: daisy wheel, dot matrix printer, drum printer, and so on. Under non-impact, make sure you know examples there and know their definition, very important to know. Good. Under non-impact, you have things like inkjet, laser printer, and and so on. So this is what you need to know concerning output devices and so on and so forth. So there everything is easy. Now before going to the CPU, because at the level of the CPU here you are supposed to master your CPU cycle, also known as processor cycle or instruction cycle. Just that here it's not more like an ordinary level where you are just saying that the control unit fetches this and so on, and no. Here now you are explaining, taking into consideration the different type of registers that exist. I think let us discuss about this before even going to memory calculation. So yeah, so let us start with this one. So let me try to see who is joining there. Okay, and I'm recording the tutorial, so the review, the replay in fact will be published on the YouTube channel. So those coming in like that, I think they will just look the review, the replay of the video. Now let me go back. Good. And at any moment, if you have a question, please you just try to on your mic and you stop me. You ask your question before we continue. Because as I'm explaining, I'm assuming that everything is well. If you are taking note also, because it's not a television, you must take note. Very, very important. Now we go at the level of the CPU. So here I'm not here to define what is LU control unit. If you are doing computer science, I'm assuming that you don't have any problem with that. Now let me go to register. So what you're supposed to know is that registers are small and fast memory found in the CPU, used to hold in fact instruction being executed by the CPU. So the definition is very clear: small and fast memory location, or is a storage location found in the CPU that hold, or is it that stored instruction currently being executed by the CPU. Just that here, advanced level computer science, you need to know this definition and also know the different type of register. Now concerning the different type of register, we have so many types that exist, but the most important one that you need to know, the most important one, let me just list them somewhere here. Now this one we call accumulator. I will define each of them. Let me just list it first. Good. The accumulator. This one we call the program counter. This one we call the memory address register. Let me just increase it. Accumulator, program counter, memory address register, memory, either you say memory data register or memory buffer. So this B here is the memory buffer register. So they are the same thing. Just to tell you that in the exam you can see either of the two. Good. Now memory data register, this now what we call CIR. CIR here simply means current instruction register, or in some textbook you just see instruction register. So it's the same thing. Take note of that. Now, so these are the most important register you need to know. There are so many of them that exist, but I will just stop here because, as I was telling you, we are GCE oriented, so I don't want to go out of the program. Good. I want us to study exactly what we heard, also answer past questions. Okay. Now, so the first thing that you're supposed to know is the accumulator in fact is a register that stores the result of the ALU. Mean that because the ALU generally is used to process to do arithmetic and logical operation. So after doing that operation, the result is being stored in a register we call accumulator. So that's the role of the accumulator. Now the next thing, the program counter is a type of register that stores the address of the next instruction to be processed. Take note of that. So as I was telling you, I'm recording this tutorial, so you can just look it after and take note, or you can take note directly. There's no problem. So the program counter stores the address of the next instruction to be executed. Now the next thing here is the memory address register. So the memory address register stores the address of the instruction to be fetched in the memory, or the instruction to be stored in the memory. Now let me come back to this. If I come back to this diagram to explain this. Now this is the CPU. Imagine that the CPU needs to execute an instruction found in the memory. So it simply means that the CPU needs to fetch that instruction in the memory, because what you're supposed to understand about the memory is that a memory is having what we call location, and each location is being accessed by an address. So this is what happens here. Now, so like if I draw something like this, let us say this is my memory here. The memory here is the RAM. Good. So you can see it like this very easily. So this is where you have your instruction. Let me say data, and here this is where you have what? Your address. Good. So it means that if I want to fetch this instruction, I need the address of the location where the instruction is being stored, and this address of that instruction you want to fetch at a particular moment is being stored in the memory address register. So this is what I'm saying. And the same thing, So when you want to fetch maybe to process, and let us say you want to store back into the memory, you need to have the address of the location, the address in fact of the location where you want to store your instruction or your data. So and that instruction on that address, sorry, is being stored in the memory address register. I think I'm clear with that. Now the next thing here is memory data register or memory buffer register. So this register now is used to store the data or the instruction retrieved at the address found in the memory address register. Because what, like this, the same example here, if I move back here, so here the memory address register was having the address of an instruction to be fetched. So when you fetch the instruction found at that address, that instruction is being stored in the memory data register or memory buffer register. So it's exactly what happens here. So the address found in the memory address register is giving us the location in fact of a particular data or instruction we want to fetch, and when we fetch that instruction, is being stored in the memory data register or memory buffer register. And this, remember that here we are inside the CPU, and this now is being processed in the CPU now. But generally this is what we call CPU. I'm coming to CPU cycle. I'm explaining the different type of register, because when I be explaining CPU cycle, we need to talk about all these registers, their roles, how they are being used in fact. Good. Now the next thing is the current instruction register. In fact, is just a type of register that stores the instruction to be decoded by the control unit. So this is exactly the role. Generally, when you describe the fetch, decode, execute cycle, you say the control unit fetch instruction from the memory, the control unit decode the instruction. That instruction being decoded is stored where? Is stored in the current instruction register, or you say in the instruction register. Now, so I think we are clear. Any question concerning these registers before I move to the next step? Any question? I'm seeing the class is silent. Any question, or is everything okay? So that let me move. Yes, one person have replied. It's okay. What about the other? I'm looking in the comment section. Only one person have replied. So please remember that when you're attending this class, it's to really gain something. So if everything is fine, you need to indicate any problem. Also, don't hesitate to ask your question, because the aim is to gain something at the end. So don't attend a class and you have a particular problem. Okay. Nice, good. So I'm receiving comment, everything is fine. Now, so we continue. Now, the next thing is, let us discuss the instruction cycle. So remember, instruction cycle, either they say instruction cycle, either they say CPU cycle, either they say processor cycle, either they say machine cycle, either they say fetch, decode, execute life cycle. So all these names are the same thing. So if you see any of this in the exam, don't be confused, they're asking the same thing. Now, so generally what happens here? So this is generally being done in, let me just describe the different steps. So here we have the control unit, here we have the ALU, and here we have the main memory, meaning the RAM. Good. And this is how the cycle goes. So you see exactly the difference between what you are supposed to know and what is being showed in ordinary level. So now yes, step 1 is the fetch, step 2 is decoding, step 3 is execute, and step 4 is store. Now, so let us go through each of them. Now, so what happens here is, this fetch, decode, execute life cycle, we have two methods of describing it, and in the GCE board, in fact, let me say in the exam, they will precise which method you are supposed to use. Now, so I'll be using, I will be showing the two methods. So the first method here is what we call the register transfer notation. Register transfer notation. So this is the first way, or let me just say the second way of representing or of describing the CPU cycle. Now what happens? Step 1, when they ask you to describe the CPU cycle, step 1 is always clear. I will just be saying it orally, so you take note after, because I don't have time to write all of them. So step 1, you will say this: the control unit fetches instruction from the memory. So everybody know this step in fact. So the control unit fetch instruction from the memory. But you're not ending here. These happen in the following steps. So in advanced level, what really adds here now is you are supposed to describe exactly what happened at the level of the fetch process. And at the level of the fetch process now, all these registers that I've described up there is being used, in fact, at the level of the fetch process. So that's why when you start by saying that, number one, the control unit fetches instruction from, or you say get if you want, instruction from the memory. These happen in the following step. So what are the different steps? The first step here is that the memory address register store the content of the program counter. Meaning that if you are describing orally, this is how you are saying it. But if you are using the register transfer notation, this is how you represent it, in fact. So please, this square bracket here simply means content. Like if I put PC inside, then I put square bracket, I'm saying the content of program counter. That's the meaning of that. Good. So this happens in the following step. The memory address register store the address found in the program counter. So this is one thing that happened. The second thing that happened is the memory data register, or you say the memory buffer register, stores the content found at the address in the memory address register. Take note of that. Now, how to represent it using the memory, using the register transfer notation. I'm going to have something like this: memory address register, like this. So let me just increase this. Good. I'm going to have something like this with 2 square brackets. Now, why? It's very easy. The first square bracket, in fact, is to have the content, meaning this square bracket here. This first square bracket is to have the content of the MAR, the content of the memory address register. But the content of the memory address register is an address. Now the second square bracket is saying that, okay, that address found in the memory address register is being accessed again. And when we access now that location in the memory, we obtain the real data, or let me just say the real instruction to be executed. And is that instruction or data that is being stored in the memory data register. So that is why I'm putting here 2 square brackets. Because if you just put a single square bracket, it simply means that you are seeing that the content of the memory address register. But the content of the memory address register is an address. And it's not an address that is stored in the memory data register. No. So it simply means that address, you need to go to the memory at that location. At the location of that address, you found its content, and it's that content that is being stored in the memory data register. That's why here I'm putting 2 square brackets. Good. So I'm coming back to this. If you have any question, just leave it in the comment section and I will pass by to read it. Now, so after this, what is the next step? The next step is the current instruction register, or you say the instruction register, stores the content of the memory data register. Good. Meaning that the instruction found here is being transferred now to the current instruction register. Why is being transferred there? Because it's there that the control unit, in fact, will decode the instruction before sending it now to the ALU for execution. So this is what happened. But before the decoding process, please, after the instruction is being stored in the current instruction register, the program counter is being incremented first. So this step is very, very important. We are going to answer past question. You'll be seeing how they are asking question under what I'm showing here. Good. So this one. This is one. So after the content of the MGR is stored in the current instruction register, the content of the program counter is being incremented. So the aim of this incrementation is just to have now the address of the next instruction to be processed. And it's after this step now that you go and say step 2. Because remember that all these things, I'm just at the level of the fetch process. But just that generally when they are asking you to describe the CPU cycle using the register transfer notation, they will just ask you to describe what happened at the level of the fetch process. They will never ask you to, it's possible that they can ask you to describe the G-code execution, but it's very rare. Generally, do not ask that because these are the main registers that you are studying. The other registers being used at the level of the other step, you are not really studying that in advanced level. Good. So now, normally step 2 here is clear. Now step 3 is what? You will say the control unit decode the instruction found in the current instruction register. Good. And what is the meaning of decoding here? I think everybody knows very well. Decoding here simply means, imagine that the instruction being fetched is 3 plus 4. Decoding here simply means that the control unit will understand, in fact, which operation is to be performed. And from this instruction, the control unit will understand that, okay, it is addition. So he's going to send a signal to the ALU because it's the ALU that is doing the execution part. If you go back to this cycle, you see that step 3 is at this level. So it's the ALU that is performing the execution. It can be arithmetic or logical operation. So decoding here simply means, in fact, determining which operation is to be performed on data, on a particular data. So this is what happens here. Now, And the next part, in fact, still under this chapter now, is now to understand format of instruction, because the type of instruction that we are studying here is what we call assembly language, in the form of assembly language. So we are coming there, you have so many questions to answer there. So that's why I'm moving fast with this one. So this is what happened at step 2. Now step 3 is what here the execution. So here you just say that the ALU perform arithmetic and logical operation on an instruction, on data, sorry. Now after that, step 4, now the result of the ALU is being stored in the main memory, something like that, and it's all. Now, so after doing this, now let us go and answer past questions. So the class will be a little bit interactive. So I will just choose one past question and answer it, and the next you will try to do so. Now wait, that thing. Okay, yeah, I have two papers, June 24 and June 25. So we'll be using these two papers in parallel and answer questions on the chapters we are actually studying. And those having other questions now on what we are studying, you still present it. So the aim at least is to touch almost everything, so that we don't just waste time on one thing. Now, this is June 24. This is the paper of June. Yes, June 24, Computer Science paper 2. And I think this question is under question. It's question 1. Yes, it's question 1. So under question 1, you have number system, you have logic gate. Very interesting question, very, very easy questions. Now, if you go to Roman 3, the B part, now they say the table below shows 6 stages in the first execute cycle in Neumann computer. Put the stages into the correct sequence by writing the numbers 1 to 6 in the right-hand column. Full stop. They say in your answer booklet, reproduce this table, replacing each description on the left with its corresponding letter. So yeah, they are just asking you to recopy this table on your question paper. Just at the level of the description stage, no need to waste your time and write all what they are writing here. No, just use letters. At the level of descriptions of stage, just write that A, B, C, D, E. They will know that okay, you are trying to write this in fact. But at the level of sequence number now you are using these digits. They say 1 to 6. To indicate now the order in which these instructions are being executed, and this is the machine instruction cycle. Now, so everybody is observing this table. So someone should on the mic and give me step 1. So between A, B, C, D, E, and from what I've explained, in fact, from what I'm just explaining concerning the first decode cycle, step 1 should be which letter? I'm waiting. Pardon? B? G. Okay, what is G? G, they say the address contained in the program counter. Yes, G, okay. The address contained in the program counter is copied into the memory address register. Perfect. Yes. So that's the correct answer here. So I don't know if I'm having that my pen. Okay. So someone here said J is number 1. Okay. Number 2, someone say F. F, let us read F. They say the instruction in the memory location found in the memory address register is copied to the memory data register. Perfect. Number 3. A. The instruction is copied from the memory data register and placed in the current instruction register. Perfect. Number 4. Number 4. E. The value in the program counter is incremented so that it points to the next instruction to be fed. Very correct. Number 5. C. The instruction is decoded. Very nice. So after decoding, now what are we doing? We execute the instruction. So you have seen that when you have revised your note, I'm not seeing how you fall. Pardon? Yes, we are okay. When you have revised very well, I'm not seeing how you fail this type of question. You answer with that, no stress. In fact, let me just take the case now of 2025. People will see 2025. This is what they asked there. 2025. I think it's question. Yes, still question 1. And play, as I was telling you the last time, always remember that computer architecture is something that you cannot really run away. You always see question on that. Prepare yourself. Now this 2025 here, still under that CPU cycle. C, the C part, in fact, Roman 1C, they say describe the fetch execute cycle. Full stop. It's not all. They say explain the use of internal register in the fetch process. So when you are describing it, make sure you do the same thing. Where is it? Good. Just like here, they did not ask you to use the register transfer notation, meaning that you'll be writing orally. Orally means what? You say step 1, the control unit fetch instruction from the main memory. This happened in the following step. Now you start by saying that the content of the program counter is being stored in the memory address register, blah blah blah. In fact, all what I've explained there is what you'll be saying. After saying all that, and before you go down to step 2, you now explain that okay, the control unit decode the instruction and so on and so forth. You go to step 3, step 4. This is all what they are waiting from you there. So generally, this is how they ask question in advanced level computer science. Good. So I think we are done with the machine cycle and so on and so forth. So while you're revising, if you fall on a question under this type of thing, you can already answer. You just try to send it now in the group, or you send it directly to me. So take note of that. Now, we go to the next part. The next part, now let me come back to this diagram. So this is exactly what you need to know. Wait, my pen. Okay, so I think we are done with the input side, the output side. We are done with the CPU side. Good. The next part I want us to study now is the storage unit. So under storage unit, let me just brief something, but I will concentrate more on memory calculation because this way students have problem.